We're entering the first of 4 factories.
This is one of the cleanest factories in the world.
How clean is clean?
Even a single skin cell can actually kill one of our chips that we make here.
Chips like these. The smallest components on today's chips are smaller than the size of a virus, approximately 50,000 times smaller than the width of a human hair. And fragile as they may be, today's most expensive chips sell for upwards of $30,000 each and are reportedly transported in armored vehicles. We're talking about the massive, highly lucrative heartbeat powering the global economy.
1 trillion semiconductor devices are shipped every year. That's 100 devices for every person on Earth.
They are the foundation of economic growth around the world, and it brings together the best scientific minds to push progress forward.
The chip industry is projected to hit $1 trillion in revenue in 2026. And thanks to AI,
Major AI breakthroughs.
everyone is talking about it.
Artificial intelligence boom.
My beat went from obscure backwater that people had sort of heard of to being the center of technology.
What is widely considered to be the most complex manufacturing process on Earth is facing the limitations of our physical world.
We're pushing the envelope of technology in multiple directions: software, hardware, chemistry, physics, in all dimensions.
Unprecedented market conditions.
Demand for AI infrastructure is absolutely massive. It appears to be insatiable right now.
Vulnerable choke points.
The modern economy is likely to collapse if something happens to Taiwanese chip ecosystem.
So just how resilient is the industry that requires this many layers of clothing to function?
See you.
Right this way. Nestled among windmills and canals, surrounded by charming cottages and cyclists, you will find Europe's most valuable tech firm, well known for
Lithography.
The lithography tools that they create are some of the most fabulously complex and difficult to perfect machines in the world.
ASML doesn't make chips. It makes machines that make chips and offers tech that no other company has been able to recreate. Lithography is a process that directs light through a series of mirrors, lenses, and a special blueprint to transfer patterns onto silicon wafers, essentially shrinking chip designs down to sizes invisible to the human eye and creating the electrical pathways that give a chip its function.
All of the manufacturers of the most advanced chips in the world, whether they say it publicly or not, use ASML's machines or are about to use ASML's machines.
The nano patterning machine is one of the most critical steps in the semiconductor making. People buy new phones because they got more capabilities for the same money. So you must find a way to print much smaller features, but at much higher productivity.
In order to make the next generation of chips even more intricate, ASML literally had to develop a way to generate a type of light that does not naturally occur on Earth's surface, called EUV, extreme ultraviolet. The system is as big as a double-decker bus, weighs as much as a blue whale, and will run customers $400 million per machine.
Why do your machines have to be so big?
That's a good question. First of all, as you want to print smaller resolution, you make the opening angle of the lens bigger.
Bigger lenses can collect more information to squeeze onto the surface of the chips.
The second reason is, in order to have the speed, you need very fast-moving stages.
Litho machines can repeatedly copy a pattern onto a wafer hundreds of thousands of times within about 12 seconds.
The reticle stage can move about 20 G, 4 times more acceleration than the most advanced fighter jets in the world. In order to have that power to accelerate that fast, you need big motors.
The smaller or more complex the chip, the bigger the machine needs to be. There's no avoiding it. All of the world's most advanced litho machines come from ASML. It is one hyper-specialized link in this highly concentrated supply chain that is under more pressure than ever before. All eyes are on the companies at the top and whether they're up for the challenge.
We design the semiconductor products that really drive the leading edge of compute.
This is AMD. Advanced Micro Devices. Worth more than $300 billion, it's a place where engineers fill their thermoses with liquid nitrogen. Where stock prices have been known to triple, AI is hot.
You hear it sizzle all of a sudden.
And occasionally, employees appear out of thin air.
Well, you guys are getting first-hand view of how this works. We're delivering server chips that go into supercomputers, networking chips that connect the world together, on down to the consoles that you use to play your latest games. But the common theme in all of them is they require certain compute capabilities and energy efficiency.
The switches in chips are called transistors. They're sort of like nanoscopic light switches that control the flow of electricity and generate the classic ones and zeros that ultimately make up every piece of digital information in our modern devices. Chips are everywhere. It's how your phone unlocks, your robot vacuum navigates, and how your coffee maker somehow connects to Wi-Fi. Sometimes.
When you think about the modern economy, right, and you think about how goods are produced today, what you recognize is that chips have become ubiquitous. It's very difficult to find anything that you can plug in or that runs on a battery that doesn't have a semiconductor of some form in it.
The stock market loves chips. Sorry, I may be underselling this a bit. The stock market is going absolutely bonkers.
The latest blockbuster AI chips deal with AMD.
I mean, holy moly, Batman, the AI rally and the chip grab, it is on in a big way.
And AMD has turned the demand for AI chips into a new multi-billion-dollar part of its business.
All right, so this is a wafer. This is how we build our products. You can see where all of the various individual chips are printed. So this wafer probably has around 300 or 400 chips printed. And after you singulate them,
A fancy way of saying wafers are chipped into individual chips, which is actually the origin of the term chip.
you have products such as this. This is a chip that would run your PC.
Basic chips are called analog or essential, and they quite simply have more basic functions as sensors or power switches. More advanced chips are referred to as, well, advanced. This could be your run-of-the-mill CPU or GPU, the brains of the computer that are computing and performing more elaborate tasks. The most specialized AI chips are designed to not only run, but create software, to process droves of data in a matter of milliseconds.
Just to see a contrast, you know, this is a PC, this is a server, this is AI, and the amount of silicon is immensely higher. This central region here is actually many chips with some stacked on top of the other. And then the 8 individual chiplets on the outside are our memory, stacked 12 layers high. And so we're able to get more energy efficient AI compute.
Of course, AI is booming. AI chips accounted for more than 1/4 of all chips sold in 2025. That figure is expected to reach more than half by 2029. Chip demand is no longer dictated by which new iPhone or PC will have customers lining up.
What has changed over the years in the semiconductor industry is since we're seeing such a surge in the need to build data centers for AI deployment and applications, we're seeing a more sustained growth period in semiconductors as opposed to the old-fashioned cyclical when we used to have Intel come out with chips that everybody had to upgrade their computer for.
Spending on AI infrastructure, like data centers, is projected to soon cross the $1 trillion mark, so the demand for these chips is there. There's just one maybe not so nanoscopic problem. How concentrated is too concentrated for this supply chain? Behind those pom-poms and smoke machines are employees for the chip giant TSMC, Taiwan's semiconductor manufacturing company. As fun as the annual company sports day looks, TSMC's role in the industry is serious business.
Creating semiconductors is the most complicated manufacturing process in the world.
To be fair, it does require a bit of choreography. Making a chip is like building a house of cards with thousands of people located on multiple continents. Everyone must place their card exactly right, delicately balanced at the perfect time, or, well, you know what happens. The majority of chip design happens in the US. Raw silicon wafers are primarily made in Japan and Taiwan, but a few other places as well. A lot of chip-making machinery comes from the Netherlands, of course, the US, and South Korea. Components within those machines are sourced from places like Germany, Japan, and the US. Then, all of those things join forces for manufacturing magic within fabrication facilities, fabs for short, heavily concentrated in Taiwan. TSMC manufactures over 90% of the world's most advanced chips, almost entirely out of its Taiwan-based gigafabs.
A gigafab is a massive chip-making site. It maximizes its output and optimizes its cost.
It created this idea of we can outsource manufacturing, give us your designs and we'll make the best chips. Doesn't matter who's designing them, you're going to TSMC and you're saying, please make this for me.
It's basically the bottleneck of all bottlenecks, smack dab in the middle of a very complex supply chain with no simple alternative.
What's called bringing up a fab, which is basically making a new factory or a new production line operational, requires a lot of experience. And so guess what? If you've got one next door that's already working, why not copy that? The logistics are very much favor building these things in what are called clusters in close proximity to each other.
These clever clusters are also, let's say, precarious.
There are a lot of ways that the supply chain for semiconductors and its broader ecosystem can be destabilized.
Taiwan's strongest earthquake in 25 years.
Disruptive side effects of the COVID pandemic. There is now a global shortage of computer chips.
A supply chain disruption in one place can cause repercussions in the industry far down the line.
To top it off, TSMC is located at the center of a decades-long geopolitical standoff.
Beijing has been ratcheting up pressure, staging its most expansive military drills in decades.
China claims Taiwan is a Chinese territory, while Taiwan maintains its independence. And that doesn't make things feel particularly stable.
There are some concerns about China's plans for the future of Taiwan and whether that could constrain the ability of United States companies to get those chips.
A February 2026 Bloomberg economics report estimates that the world economy could lose $10 trillion if a conflict were to erupt. With Taiwan hanging in the balance, global superpowers are making moves.
The government of the United States has said, hey, guess what? This is strategically important to us. It has massive security implications.
The defense industry needs very highly advanced chips that are impervious, for example, to space radiation, to power satellites and planes and things like this. So there's a defense industry motivation for governments to make sure that there are the right kind of semiconductors produced within their country's borders.
China doesn't feel that it can depend on the U.S. It believes in self-reliance and technological supremacy as well. But basically, it doesn't want to be left out. So it wants to develop its own homegrown chip industry.
And where does Huawei come in?
Well, Huawei is China's national tech champion. It's a company that's known for its hardware prowess. Back in 2019, the U.S. had imposed sanctions on Huawei, basically cutting off its ability to get the components it needs to make its products. And there was a feeling that Huawei was in a lot of trouble.
At the time, China was a late start into chip manufacturing. Less than 10% of the country's chips were being supplied by Chinese companies with less advanced tech than foreign firms, which is at odds with the fact that China is also the world's largest market for chips.
China has a massive middle-class consumer base that it can sell electronics to. So if it could make and develop these capabilities in the chip industry, then it's almost supportable on a domestic basis.
But China has been notoriously secretive about its chip industry.
No one really knew where China stood. We had heard that Huawei was building some chip factories in secret. We identified 3 factories deep in the bowels of Guangdong, and I got the location. And when I got there, I was surprised.
The site was evidence of China's major domestic manufacturing efforts underway to skirt US sanctions.
We all thought that this wasn't possible because you need so much money in order to build these chip plants.
Estimates suggest building a leading-edge chip plant requires at least $30 billion in capital. Nonetheless, in 2023, Huawei shocked the industry with the debut of a China-made advanced chip that proved an unexpectedly rapid development and capability. China has also become the world's biggest producer of analog chips. But Chinese progress in advanced chip making has been stalled by fluctuating US regulation around access to state-of-the-art Western chips and chip technology. ASML's highly coveted advanced lithography machines are among the technologies blocked from being sold to Chinese companies.
China's advantages, they're spending and investing a lot of money in creating their own chips. The Chinese government launched a $50 billion chip fund, allowing a lot of these local chip makers to tap into in order to develop their chip-making capabilities. You also have all these big private tech companies, Alibaba, Tencent, also providing money and support, backing a lot of these startups.
Money is the name of the game. The Chinese government is considering incentives valuing up to an additional $70 billion to support domestic chip making. Meanwhile, the US is still doling out money from the Biden administration's $52 billion 2022 CHIPS Act in a major reshoring effort of its own.
Reshoring means bringing factories back to a certain country so that the physical ability to manufacture semiconductors resides in that country.
In 1990, nearly 40% of the world's chips were manufactured in the US. In 2024, it was only about 10%, so the US has ambitions to send that percentage climbing again.
The United States has never been the cheapest place to produce semiconductor components. Our labor costs are high, our regulatory burden is high, but there is an incentive now under the current administration and another prior one, which involves subsidizing the creation of more manufacturing here in the United States.
About 7,000 miles from the TSMC gigafabs in Taiwan, there is a site, or collection of sites, that have earned a name inspired by none other than the birthplace of chip innovation. Welcome to the Silicon Desert.
This place, a few years ago, it used to be desert. And in a few years, we will have a little city here of fabs. Everything will start being like a science fiction, highly automated, producing thousands of wafers very soon.
On the one hand, the desert is good for chip fabs. Low humidity, decreased risk of earthquakes and floods, cheap land, and, of course, some tax incentives. On the other, the chip infrastructure has to be built up from scratch. To date, TSMC is committed to investing $165 billion in the Arizona fabs and is scheduled to receive $6.6 billion in direct funding from the CHIPS Act. As TSMC makes a splash with its first operations on US soil, major expansion efforts are also underway by the OG American chip company. Do you know the one? Think back to your high school backpack.
There's a better way for everyone. From the company that invented the integrated circuit, Texas Instruments, the better way keeps getting better.
Everybody says, oh, the calculator company, right? And the reality is we do so much more than that. Our foundational chips are the backbone of essentially all modern technology as we know it.
Okay, so the calculators are cool, but this Texas Instruments story is about a different equation.
If it plugs into the wall or has a battery, it very likely has one TI chip in it. We have 15 manufacturing sites globally, and these manufacturing sites work together to provide tens of billions of chips every year globally to our customers. And for perspective, that's tens of thousands of chips coming out of TI globally every single minute.
That is a whopping 100,000 customers and 80,000 products. TI makes the kind of chips that perform more simple tasks, like sensing temperature to prevent overheating, or managing power as it moves through a device, the chips that keep our technology safe and running smoothly.
One of the most important things about the industry that you have to understand is its volume economics. Making a lot of chips as cheap as you can and selling them for as much as you can is the way towards victory.
Some of TI's chips sell for just a few cents each. They're cheaper and easier to make than today's leading advanced AI chips, meaning it's cost-effective to utilize lower-tier or even hand-me-down production equipment. But the company has made the countercurrent decision to invest $60 billion in advanced chip manufacturing tech.
We're actually in the subfab. The clean room will be just above us.
The details all come back to those shiny wafers.
Maybe you can come here and help me hold this, please?
This is a 200mm wafer, the size used by most analog chip companies. This is a 300mm wafer, primarily used for more advanced chip manufacturing. These are TI's big bet.
So going from 200 to 300mm increases the surface area on the wafer by 2.3 times.
Meaning 2.3 times the number of chips.
So when you look here, there's kind of a collection of different chips, and you can see everything from, really big products here, all the way to the very small, tiny ones.
Pause. Let that sink in. Those are chips.
Yeah, it's quite amazing, isn't it? I think if I picked it up, you wouldn't be able to see it. I think it's about the size of a pepper flake, and in fact, very glittery.
At that scale, 2.3 times the number of chips could mean a competitive advantage of hundreds of thousands more chips per wafer.
So from this vantage point, you can get a sense of scale of this site. This will be TI's largest mega site. Over 5.5 million square feet, the same square footage as 2 Empire State Buildings. Wow. It's a huge site, mega site.
While TI doesn't make AI chips, it's hoping the current landscape propels demand for its essential chip business.
I think what we're seeing in terms of the growth and expansion of the whole industry is a mixture. We always have the nuts and bolts chips, but we also have AI pulling along those nuts and bolts chips too, because you can't build a server for a data center without some lower end, cheaper chips that do some of the grunt work, if you like.
I'm bloody freezing.
All right, get into those warm bunny suits.
So we're going into the first part of the clean room that hasn't had equipment installed yet, is that correct?
Yeah, we're entering into the north side of the first of 4 factories here in Sherman, Texas. This factory is 100% automated. On the ceiling, we will have over 15 miles of automated track. Each one of those cars carries material around the factory. Bringing up a 300mm factory has the most advanced manufacturing equipment in the world.
Texas Instruments projects this site will soon produce hundreds of millions of chips every single day. If all of this investment pays off in the margins, TI will increase its lead as the #1 global supplier of analog chips and prove advanced manufacturing's value for even the tiniest ones.
A couple of decades ago, chips in general were servicing behind the scenes. Today, I would say chips actually define infrastructure. They define communications or people mobility or defense or AI.
From the chips powering our devices to the fabs where they're made, the industry is experiencing pervasive change. The demand from AI and our ever more technologically dependent world is forcing a global rethink of the fundamental building blocks. But one thing is for certain. Innovation is underway.
We might be looking at the news and seeing politics take center stage or other disruptions. Be aware that companies are going to be focused on investing in the new product, in the new design, in how to save on costs. They're going to be focused on innovation if they're doing things correctly.
For years, this industry was mired in this win or loss brutal economics, trudged towards the future, and now we're seeing all kinds of excitement of people talking about chips in a new way.
Plain and simple, the chip industry is evolving to meet the moment, and it's...
Am I allowed to say the word sexy?
Why, yes, you absolutely are.